This video is over lateral surface area, total surface area, and volume. The purpose of the video is to illustrate the differences in lateral surface area, total surface area, and volume. The learner will be able to communicate the difference between the three, as well as give examples of each of the three. This video will be used in a high school geometry course. Lateral surface area, and volume. Today we're going to look at the three formulas and some examples of when we might use them. When do I use which formula? How do I use the formulas? Why do I use the formulas? Most often when this question is asked, this is what I hear. Lateral surface area is where we only find the surface area of the sides of a polyhedron. So we're not going to include the area of either of our bases. When finding lateral surface area of a cylinder, we're going to use the formula 2 pi RH. An example of when we might use lateral surface area is if we wanted to find how large a label would have to be to go around a can. Because the label is not going to cover the top or bottom of the can, we only want the lateral surface area, or how far it is around. Lateral surface area of a prism we're going to find by finding the perimeter of the base and multiplying it by the height. How many square feet of wood would you need to build a fence if it's going to go all the way around a structure? Well, you're not going to have fence on the top or the bottom, therefore we'd use lateral surface area, and because it's a prism, we would use our formula for lateral surface area of a prism. Or what if we wanted to paint the walls of a room? Unless we're painting the ceiling and floor, we'd want to use lateral surface area. Now let's look at total surface area. Total surface area is going to include all the area of all the surfaces of your polyhedron. So not only the sides of your polyhedron, but also your bases. To find your total surface area of a sphere, you're going to use the formula 4 pi r squared. Notice we didn't talk about a sphere when we use lateral surface area because a sphere has no sides. How much material would we need to make this volleyball? Well, there's nothing on the inside of the volleyball, therefore we would just need the total surface area of our ball. To find total surface area of a cylinder, we use 2 pi RH plus 2 pi r squared. Notice that the first part of that, the 2 pi RH, is the same formula we used to find lateral surface area. Therefore, we're still finding the lateral surface area, and then we're just adding the area of the two bases. We would use total surface area to find the total amount of materials we'd need to make this Pringles can, because we would need both the sides, the top, and the bottom. To find total surface area of a prism, we do the perimeter of the base times the height plus 2 times the area of the base. Again, notice the first part is just our formula for lateral surface area, and then we add to it the area of our bases. How much cardboard does it take to form this box? Because we would want the sides, the top, and the bottom, we would use our total surface area formula. Volume is going to formulate the measure of all the inside of a polyhedron. So we're not just talking about the outsides anymore. You can think of it as how much would it take to fill up the shape or the polyhedron. To find the volume of a cylinder, we use our formula, the area of the base times the height. Notice that the capital B stands for the area of the base, and in a cylinder, that base is a circle, so we would use our pi r squared to find the area of our base, then multiply it times the height. How much peanut butter can fit in this jar? We would use volume to find the answer to that question. Notice we're no longer talking about the outsides of the jar, we're talking about what can fit inside. The formula for volume of a sphere is 4/3 times pi r cubed. Notice that's a pi r cubed, not squared. We would use volume to find how many materials it would take to make up a baseball. Because a baseball is solid all the way through, we would use volume instead of surface area. To find volume of a prism, again, we use area of the base times the height. The only difference is the area of your base will depend on what shape the base is. In this case, we're talking about a rectangle, so we would do length times width. How much water does it take to fill up a pool? Well, because we're talking about filling something up or how much would go on the inside, we would use volume. I hope that this video helped to clear up when we'd use lateral surface area, when we'd use total surface area, and when we'd use volume. Hopefully, now what you're thinking is, oh, I get it. I use lateral surface area when I just want the area of the sides of a polyhedron. I use total surface area to find the area of the sides and bases of a polyhedron. And I use volume to find the inside or how much would fill up the polyhedron.